right. Hello, and welcome everyone. Welcome to another episode of BIM After Dark Live. This is episode 65, believe it or not. Welcome to this Thursday night live stream. If you're looking at this in the future, welcome in the future. I've got an awesome guest from Lake Flato Architects. He's a returning guest. He's not talking about Enscape this time though. But stick around. We're going to be talking about energy modeling with Revit and what it's like today. I'm super excited about it. I haven't messed with any of these tools in quite some time, and I'm curious to see how they've changed and what the workflow is like, especially on the early side. If you guys, similar to my coordination spiel from a year ago on the design side, this is something that probably everyone should be aware of and be able to do if you are designing buildings. So super excited to see Revit and Insight 360 and how all of that combine. A couple of housekeeping items. I think last week I mentioned there was a couple live or free resources that weren't working, including my family cheat sheet. All those links are working now, so if you're interested in any of the free resources I have, go on over to free.bimafterdark.com, and there's a twin motion course, an ebook, a bunch of ebooks, cheat sheets, all kinds of cool stuff. But I know that last week you guys were telling me that it wasn't working, so I fixed all of that. I'm checking out all the chat. I will be checking the chat the whole time. We are live, so feel free to ask questions, and I'll check them out along the way. I truly appreciate you guys joining me live and joining the show. Last but not least, subscribe to the channel. If you look down on the bottom somewhere, it says we are actually, I think it's less than 200 subscribers away from 50,000. Which is pretty awesome. Considering when I started this live stream, I think we were at like 18,000. So pretty awesome. And if you have not subscribed to the channel, please do, because, you know, why not have a Revit channel and support the Revit channel, the Revit Kids channel, to make it to 50,000. And maybe I'll do some free giveaways or something when we hit 50,000, which would be pretty fun. Okay, so before we jump into introducing our guest tonight, I did want to thank our title sponsor of the show, which is Polycam. For those of you not familiar with what Polycam is, it's actually an application for your iPhone or iPad. On your iPhone, it utilizes your LiDAR scanners, and I believe that's only 11 and 12 iPhones. And on any phone that does not have a LiDAR scanner, it will use photogrammetry. What this application does is actually scans and builds and develops meshes, and then also can export in various forms like point clouds. I'm actually going to be showing you the workflow for Polycam to Revit next week on the show. So tune in. It'll be a special edition on a Tuesday, because for those of you who do celebrate or at least get together family, next Thursday is Thanksgiving, so we'll be doing it on a Tuesday night. So definitely check out the show next week. If you're interested in checking it out, try it out for free. The QR code right here will send you there on any of your devices, as well as heading on over to polycam.bimafterdark.com. Definitely check it out, and if you're interested in the workflow, tune in next week. All right, so thank you, Polycam. Now, it's about time we finally introduce our guests. Actually, Dan's already chatting in there. I see you, Dan, you're in the chat window over there, so Dan's introducing himself, but I'll pull him into the screen right now. Dan Stine, what's going on, man?
Hey, I'm all right. How are you doing?
All right, man. Thank you for coming back on the show. I appreciate it.
Heck yeah, glad to be here.
So Dan was, for those of you not following, for the past 65 episodes, and I'll put links to all the previous episodes Dan was on, but Dan was kind of our resident Enscape guest for a little while, and I appreciate that, but it's nice to have you come on and talk about something else that I know you're also passionate about and have quite a bit of knowledge and experience in. So energy modeling, it's something that I don't think people touch enough of, and so I appreciate you coming on to talk about it. Maybe before we jump into the actual content, for those who aren't familiar with you, maybe a quick, brief little bio on yourself and how you got to be here on BIM After Dark Live.
Sure. I actually have a slide for that, so I don't know if you want to wait and just
no,
have
go
me.
for it. If you want to pull up the slide, go for it, man. I'll flip over to the screen when you're ready, and we can start right there. And again, guys, I'll be checking out the chat. Joe, how's it going? Jackie Watson, hello. Miguel, Dan Stine, hello in the chat. Alejandro, awesome. Welcome, guys. Thanks for joining tonight. All right, man, go for it.
Yeah. So my slides live.
Your slide is live. Yep.
Okay. I just have a few slides I want to show just to introduce the topic, myself, Lake Flato. And actually, I have this slide deck that I've gotten some use on recently. I did two presentations last week touching on this topic, not quite the same level of detail that we're going to cover, but did one for Pratt and then another one for the University of Michigan.
Awesome.
So this is me. I'm a Wisconsin registered architect. I teach graduate architecture students at NDSU and previously taught in their interior design program. Earlier today, I did a presentation for the University of Minnesota interior design students on lighting design.
Oh man, you did back-to-back presentations today?
Yeah, today was a busy day.
Oh man, thanks for jumping on then.
Yeah, no problem.
I know what that feels like. I've been there.
It's fun though. I love it. I'm gonna sleep well tonight, but I love it.
Right.
And I've written 14 textbooks. One of them is the #1 Revit book in the academic market in North America. Have BIM chapters that I write blog posts for. That's gotten popular, not quite as popular as 50,000 followers on YouTube. But it gets like 20 to 30,000 views a month. And most of that's from searches, people finding old posts. But I also I'm commissioned by Enscape to write blog posts for them. International speaker. I'm currently the chair of the National IES, the Illuminating Engineering Society BIM Standards Committee. And then kind of related to this topic at hand, I'm a co-author of a document that's not out yet, but Lake Flato and Bureau Happold, and then two other individuals, so 6 of us, 2 from Lake Flato, wrote the AIA Climate Action Guide for Practice, which is meant to parallel the AIA framework for design excellence. And here's my class at NDSU. Actually, this is an old picture pre-COVID. Fargo, North Dakota. And then Lake Flato, quick highlight for anybody who's not familiar. We're based in San Antonio, Texas. We have an office in Austin. I'm actually in San Antonio. Beautiful weather. Got my window open behind me right now.
A little different from where you came from.
Yep. Actually, yeah, I forgot to mention, I used to, my picture there of biking to work in the winter was one of those, you tell your grandkids about, walking to school uphill both ways. I biked in up to -20 below, and the elevation difference between work and home was 500 feet. So pretty intense. Good exercise.
A little different in Texas. A little different.
Yeah. So Architect Magazine ranked us the #1 firm in their 2019 top 50 list. We've won more of the AIA COAT awards than any other firm in the US. And we've been a AIA 2030 commitment signatory since the year it came out. So for 10 years now, which is pretty cool. And we have 6 books published and a 4th one coming out by Rizzoli on our residential projects. I saw a copy of it in the office earlier this week, so maybe it's actually already out. I don't know if that was an early copy, but it's pretty awesome. And then actually, should I just go through these slides that I have, or do you want to chat about something else first?
No. I mean, I think we can go through what you've got for the moment. And
yeah, I'm going to go through these really quick, but so we have different studios in the office, ranging from residential to higher ed, development, ecocon, and we do projects. About 50% of our projects are national around the US, with about half of them being regional, the other half. And here's some of the AIA 2030, the AIA COAT top 10 awards that we've won for projects around the country. Some of our results. So higher is better, and orange is us, and gray is the national average for firms that report their energy modeling results for projects. There, if you sign the 2030 commitment, you're obligating your firm to report for the entire portfolio your predictive EUI numbers, and that's each year that you touch the project. If you're working on it one year in just an SD and the next year in DD, if it's a really big project, you're reporting on that same project each year. I'm just gonna go through. So we have this design performance action plan that it's our internal guide to help us stay on track for our goals and define how we approach projects in terms of practice, people, and planet. Those three main goals and subtopics. Just picking a few out of this document. Health and wellness, integrating indoor environmental quality goals for every project. So on the right is Climate Studio daylighting analysis that's done in Rhino. Climate Studio is an add-in to Rhino. It's actually the replacement for Diva by the same company. In the lower left is this quality views simulation. This was actually done with the Grasshopper script, but recently we had hired Michael Kilkelly to make a Revit add-in for us. So actual API developed tool that can do this on any Revit floor plan, which is pretty awesome. And then the topic at hand, I won't spend any time here because we're going to be talking about this a lot. And then embodied carbon, we use Tally quite a bit to do that study. It's an add-in for Revit, originally made by Karen Timberlake, but now handed off to Building Transparency, who also makes EC3. I actually used this workflow that we're going to look at tonight to do work on this white paper with one of our MEP consultants in Austin called WGI that looked at different wall types and roof insulations. And then also, this was actually for a project in San Antonio, but we then decided to take that same project and put it in different climate zones and sort of looking at this idea of the point of diminishing returns for insulation thickness. And so there's a link at the bottom. You can go check that out. This is a kind of a workflow overview of our approach to early energy modeling. And I guess not necessarily early because this ends with post-occupancy analysis, but we start by setting goals and then try to do massing studies early on, looking at different shapes and orientations on the site. And then that continues to develop. And let's see, I'm going to actually come back to these later. And then the very last thing I wanted to show you is just one of my favorite Lake Flato projects. It actually won an AIA Honor Award, and it's right here in San Antonio. So Confluence Park, and we're currently continuing to do post-occupancy evaluation, monitoring the actual energy use of the project, and the pavilion area here has these really cool concrete structures that we did a lot of parametric design on. And I have actually fairly recent blog post that shows a lot more about this, the design, and here's some of the post-occupancy results. And we were just out there recently because it stopped working and we had to go put hands on it and figure out what was going on, which is always fun. So that's a quick run through. Just
no, that's
sharing.
Great. So I think stuff. So before we start going into process stuff, I did have one or two questions that I'm interested in, just generally, because I think there's probably folks out there who maybe are tuning in that they live and breathe this stuff every day, right? Maybe they're living and breathing ASHRAE standards and energy modeling and that part of it, but then there maybe are designers or architects out there who don't even touch this stuff, right? And so I'm curious, at Lake Flato at least, is this something that you have dedicated specialists doing throughout the process, or is every design team member sort of understood and bought into this process and maybe even learning, if you're a designer, running these early studies or insight on their own, or how do they approach that? How do you guys approach
Yeah,
that?
that's a great question. It's almost like I asked you to ask me that.
No, you didn't. You didn't. I never get fed questions for the show. I
that
promise
because
you
that is
guys.
that is an awesome question. And in fact, I just did an Autodesk University class that had like 500 people signed up for it, and the title was Implementing Early Energy Modeling
Mm,
in Architectural Practice. And of course, at the point I came onto the firm just a year and a half ago now, which is crazy that that much time
I
has
know.
gone by already.
I think you
Full,
announced it on the show, and it's already been a year and a
yeah,
half,
I
right?
did. Yep, fully been here, after the pandemic started. But
Yep. Yep.
of course, we've always done energy modeling. So the context here is implementing it more broadly at the design team level. And
Mm-hmm.
part of that is because of this workflow. And interestingly enough, like I say the same thing about Insight that I say about Enscape. Neither one of them are the best tool at what they do, but they're the best workflow.
Mm-hmm.
Totally.
Mm-hmm.
Like
Mm-hmm.
energy modeling, there's train trace and IES and
Mm-hmm.
really complicated tools that you need to be a mechanical engineer to use, or
Right.
other tools as well that just aren't as easy to use. Enscape, same way, right? There's so
Mm-hmm.
many tools out there that could do some crazy, super photorealistic renderings, but the
Right.
workflow is what makes 80% of our staff use Enscape. I just checked in our license usage recently, and it
Mm-hmm.
lists for the last 180 days,
Mm-hmm.
80% of our staff has touched Enscape.
That's awesome.
So similarly with this workflow, it is so easy, and you're going to see this because I'm going to start from an empty model and show you how to do it, a 8-story building calculation
Awesome.
in no time at all.
Great. So that's awesome. So then everyone has the ability to, and I'm assuming everyone sort of will probably learn how to throughout their process or throughout their time. So that's awesome. And of course the tools are what are allowing it to happen, which is great. Awesome. So great.
Well, real quick too, the best part about this is if you have Revit,
Hmm.
it's completely free. I mean, you're paying for Revit, but there's no extra cost for anything that I'm about to show you.
I know all
And
the
so,
Autodesk skeptics are like, really?
yeah,
Free? No.
yeah, it
That's
is.
awesome. Yeah.
It's pretty crazy because all the calculations are done on Amazon servers, and
Hmm.
um, it's and the other thing is the AI 2030 commitment that I mentioned. They do this annual report called By the Numbers, and
Hmm.
I mentioned this in my blog post today about this presentation tonight, that energy modeling is essential, and they show statistically, and seems like a truism or circular reasoning, but or just common sense maybe is
Yeah.
the best way
Yeah.
to say it, right?
Yeah.
Projects that do energy modeling perform better.
Right.
But seems like common sense, but
It
it's
does.
not being done as much as it should. So
Hmm.
these conversations need to happen.
Yeah, and I'm interested, and the reason I sort of asked the question too is, in my experience and in my lifetime of working in AEC industry, you really only hear about this at the larger firms doing very specific work. For example, especially in my area, it's usually only where it's necessarily required, and maybe that's public work or universities or owners that are, a little bit, more forward thinking. Or thinking about this stuff or care about this stuff. But I'm also interested in, like, if you're the sole practitioner, right? And you're out
Mhm.
there, designing buildings using Revit or houses and home additions, like the fact that these tools are there and accessible, and like you said, technically free because you pay for Revit. You can do small, energy models of your residential house, even if it's just to see what happens if I change this window
Yeah.
from a 6 foot to a 10 foot or 12 foot, or what if I rotate the house just a little bit on the site. And that to me is the super interesting part of the workflow. It's not necessarily the big implementation on the large firm scale, but it's also on the sole practitioner and the conscious architect, which I think I imagine that if you're designing houses for a living, you're probably conscious, and you probably do care a little bit about the impact of what you do on the globe, right? And so that's where I'm very interested in it. So what we're gonna do real quick is, before we jump into process, which I'm super excited about, I'm sure everyone came and can't wait for that, we are gonna take a quick break for the tip of the week, which is a new segment here on the show this season, sponsored by Enscape, believe it or not. So anyone not familiar, this is the Big Bad BIM tip of the week. And so it's a segment here on the show Sorry, the audio just went really high. It's a segment here on the show where we highlight your favorite Revit tips. And by your, I mean you, the audience. And so every tip here in this segment has been submitted by an audience member. Sometimes they record videos and send them, like tonight. And sometimes it's just a text thing, and I maybe record a video. So if you are interested and have your favorite tip that you'd like to share and see on the show, send it my way. Hopefully I'll choose it, put it on the show. And if I use it on the show, I will send you a free t-shirt. So this week's tip, I wanted to hurry up and get in the show because it actually kind of builds on the last 2 episodes of Family Creation, and it's from Beth, and it's actually a Windows tip that will help you in Revit. So Beth, thank you for sending this. Thank you to Enscape for sponsoring this segment. If you're interested in Enscape, head on over to enscape.bimafterdark.com and you can save 10% off. So let's jump into the tip right now.
This tip is actually to do with a Windows hotkey that I use a lot in the Revit environment. If you hold down the Windows key and hit V, like you're pasting, but instead of Control V, you're hitting Windows V, it will give you a history of your clipboard. So if you're going through and you need to be copying and pasting multiple things multiple times, but you need to refer back to things, this is great. So for instance, I can paste in formula and then overwrite the element that I need to overwrite for this one, because I'm building in fail-safes on this downspout family. And then I can continue to do that, and it's a lot quicker than trying to go back and copy and paste over and over again.
Awesome. So thank you, Beth, for that tip. Really awesome. Eric did mention in the chat that you do need to turn it on first. So for those of you that haven't done it before, if you hit Windows key V, it brings up your paste history. But do it right now, and then it'll say you want to turn this on in Windows, and you turn it on, and then it'll start saving it. So thank you, Beth. That is an awesome tip. I appreciate it. And again, if you guys have a tip that you want to share here on the show, be sure to email me your tip, and if I choose it, I'll send you a free t-shirt. So Beth, there's a shirt coming your way. All right. Awesome. Dan, let's do it, man. Let's talk process.
All right.
I'm ready, man.
All right. I'm just going to jump right in, and
yeah.
There's so many ways of looking at this, but I'm going to show you the first way in which you should approach energy modeling. After doing some sketching, I'm a big fan of sketching. 2 of my books are on architectural hand sketching, ironically. But after you've done a little bit of that, let's do some massing and look at how the building might perform on a specific site. So we're going to make an 8-story building. So I'm going to do a little quick array. I'm going to turn off grouping. So that top one's the roof, which we technically don't need, but this is important that we need the levels, as you'll see in a little bit. So our next step is to go into massing, and we're going to do an in-place mass, turning on massing visibility, give it a name, which doesn't particularly matter. And as we'll see in a little bit, thermal zoning is really important, and ASHRAE 90.1 Appendix G, which is basically that defines how you should do early energy modeling, talks about 15-foot perimeter zones to properly develop solar heat gain on different sides of the building. So anyways, I need to be more than 15 plus 15, right? 30 feet, and then have some area in the middle that is going to allow us to do what's called perimeter and core thermal zoning. And then I'm going to go to this elevate or a 3D view just so you can see this become taller. And snap that to the roof. We can look at it in elevation. It's the right height. I'm going to hit finish. And one thing that's really important to make this become part of a actual energy model is to apply mass floors to it. If we have a copy or another mass nearby that doesn't have mass floors, this might represent an existing adjacent building, right? That's going to block some sun at different times of the day. So for the one that is the building, we need to apply levels to it. Most of what I'm going to talk about actually applies to whether it's a mass model or Revit Elements like walls and actual windows and roofs, but this is one of the few things that's a little bit different. As soon as you do that, we have these analytical floor plates that are showing up. They're not real floors, they're just mass floors, and they have an area associated with it. So totally separate from any notion of energy modeling. You can create a mass floor schedule and all of a sudden get your gross square footage of your building. So floor area, level, grand total, the floor area. You can tell I've done this before. And now we have the schedule. So we have 30,000 square foot building that we've just modeled. And then if we wanted these mass elements can be a lot more complicated so if we select this top surface while we're in edit mode for this mass, and then use something like the rotate command. Oops, click the wrong button, shaded. So you can see each floor plate now is completely different. And of course, the area schedule or the floor area, the mass floor schedule is updated. There's lots of different adjustments that you could continue to make to this. So I'm just going to undo this and keep it simple for now. But that what I just did there would totally work, but we're just going to keep it simple. So basically we have the geometry part dialed in. We have the mass, we have the mass floors applied, and there's only one other thing that we need to do. If we go into energy settings, most of what you see in here can pretty much always stay the same. There's this notion of the 15-foot perimeter zone depth. This is that thermal zoning that I was talking about. The ground plane is specified here, and the phasing. Revit doesn't care about what view you're in or what's hidden. There's no way to sort of hide stuff. So the phasing is the only way to really control stuff if it's in the future or in the past. The only thing we really need to do in here is set the building type. This is going to get us an accurate ASHRAE 90.1 baseline. And baselines are really important when we're talking about energy modeling, whether you're doing the what code you're following, or if you're looking at existing buildings stock, maybe whether the firm has it or you're looking online, having some sort of baseline to gauge whether you're doing better or not is important. And so there's different ways for a architectural building to basically, code paths that you can follow, and ASHRAE 90.1 is one of them. So that's the one that Insight lists. And then also another benchmark is the Architecture 2030. And you can go to their website and use their zero tool to figure out what the benchmark should be for your building. But Insight will give us that as well, because that zero tool has an API that Insight connects into. So the main reason for picking this is to make sure you have the right building use type selected. And if it's a multi-story building and you go into the GBXML file, you can see there's an elevator load in there. And if it's a restaurant, there's going to be equipment loads for the kitchen, and all that stuff is pretty accurate. Later, we're going to come back and talk about like wall assemblies and roof assemblies, but literally all I did in here was specify the building type, or at least I verified it. I actually didn't even change that, right? And so now we're ready to create the energy model. and push it out to the cloud. What's really interesting is that the orientation and actually the R values and glazing properties of anything, it doesn't matter yet, even the window to wall ratio. Actually, that is one thing that I can set here if I want to. So take a note that I set the window to wall ratio to 30%, and I'm going to show you in Insight where that shows up. And now I'm going to create the energy model, which basically it's an automated way of creating what every single program that does energy modeling needs is a simple single plane that represents each surface, and nothing any more complicated than that will work in any program. So, and usually the process of creating that simplified model is a whole separate effort that's quite a bit of work. So here we're actually in a view. It just created this 3D view called Analytical Spaces. And if we select one of these spaces, here's that 15-foot perimeter zone. So this is sort of simulating a row of offices or conference rooms or something that's on this exterior wall. And then there's an interior zone, the core. And so there's one for each orientation. I actually have a whole bunch of blog posts queued up here to show you. There's a post on my blog called Thermal Zoning in Early Energy Analysis, and you can be off by as much as 10%. Here's a quote unquote skyscraper with thermal zoning without, and it's just not properly developing, right? You could have the loads. You could have cooling required on one side in the morning it's getting beat with sun, and the other side of the building is still relatively cool outside and needs heating. So this also references a report, a white paper that was done by Lily Smith. Another thing that is here that's not visible right now is something called analytical surfaces. I always like to duplicate this. If I had my way, Autodesk would do this automatically. So analytical surfaces. And then I'm going to go into the visibility settings and turn off all of these model categories, which actually for this massing model, none of this even exists anyways, but Autodesk has it set up to just show the things that are actually considered when you're creating an energy model. There's a lot of stuff completely left out. It's never going to look at generic model or specialty equipment. There's too much junk on those categories. So just the main building elements, and then some of those are even grayed out or half-toned. So I'm just going to turn that off altogether. And then on the analytical model categories, I'm going to switch this from spaces to surfaces. And notice how architecture is the only one on here. There's a ton of structural analytical elements that we don't care about. So I'm just turning those off. So analytical spaces was what we were looking at. And then analytical surfaces with a bunch of subcategories are what we're going to see next. And so here's our 30% sort of faked in window to wall ratio. So this is useful until you actually start modeling windows. Notice in the properties, it's already got solar heat gain coefficient, visual light transmission, a U value, and it knows it's a fixed window. If you pick a piece of wall, it knows it's an exterior wall. It has an R value, a thermal mass value. So those two pieces are really critical. Some programs in this same sort of category of early energy modeling don't include thermal mass, which isn't really accurate. And then for the roof, you can see that it knows just all we created was one extruded mass, right? And it already has this notion of 30% window to wall. It has a roof. If I pick one of these floors, it knows it's an interior floor. But if I go all the way down to the bottom and pick that floor, it knows it's a slab on grade. And if I would have had a floor that existed below level 1, it would be a below grade slab. I actually have a little bit more complicated model I'll show you later, that has some more variations on that, like how the vertical wall also gets split up more accurately.
Awesome. So I think first I will mention that any of the links that you mentioned, Dan, I'll make sure to are in the description here on YouTube, as well as on the blog post tomorrow on my blog. I guess maybe before we run the analysis, I did want to sort of recap for everyone, because that's awesome, and that's a lot of information, and I think
Whirlwind. Good thing it's being recorded.
yeah. But really, it's really, you mentioned, you made the mass, which is one thing, right? So we're starting with a mass, and depending on your workflow, that's probably where you're starting. I would think that's where a lot of designers will start, with a massed out object. You're making sure you're slicing into floors. You're going to, and I don't think you mentioned it, maybe just in case people couldn't read it, it's under the Analyze tab when you go to the energy settings, and that's where Dan set up, made sure that it was an office setting, make sure that level 1 and all those cool things were set up. And then under that same tab, the Analyze tab, is where you created the energy model. And then once you're in there, that's where you can do all this stuff. And so I guess real quick, the question I have is, and I'm sure when you show a more complex example, but just thinking back to when I was way back, I don't remember, it was 2012 maybe was the last time I even did this, but I was taking masses that were created for design options. We had 3 or 4 different options, and I do remember at some point in time having to sort of tweak the masses a little bit to make the energy model look correct, as in, like, I masked it for one purpose, which was maybe visualization and design, but I did have to tweak them a little bit because of the way Revit was interpreting, right, the surfaces. And so I guess to folks maybe who are doing this beyond a box, do you have any tips or things that you can think of when to look out for when you have a mass of your building and you're sort of looking at this these analytical surface models, and you're like, that doesn't quite look right to me? Is there sort of tips and tricks that you can think of as far as shaping your mass to help with that automatic creation of analytical surfaces?
Not really. I think it's probably gotten better since we've experienced that, and even the ability to select some of these surfaces and see as much information and properties now that we see, just to sort of double check some of the thermal properties. So there is a setting back in the energy settings dialog for the analytical space and surface resolution, 2 settings that you can crank way down that will yield more accurate geometric results. For when it's a more complicated building, it's set a little bit higher just to make it run faster in Revit, because it's doing a pretty expensive, in terms of resources, voxel method to create the energy model. Like, even in a more detailed Revit model, it's actually doing something like unto Minecraft, where it's doing this cube at the geometric center of the project and growing out. So it doesn't need any Revit rooms. It doesn't need to know what's an exterior wall or an interior wall, or what's that occupiable space versus a plenum. It actually figures all that out on its own. It's a pretty intense routine. So there's always quirky things that do happen, and I guess I can't think of any that happen enough to answer that question better than what I just did. I did forget a huge thing, though.
I see your screen and I'm like, oh, I see now what you forgot to mention.
So what's really funny is once you create this energy model, which I mentioned is an expensive resource, and that's why you have to create it. If you make a mistake, like I did, you have to delete the energy model and recreate it, because this is a one point in time thing. So like the building type being office, and the window to wall ratio being 30%, and the location being Boston. All those things now are embedded in this thing. Some of it you can't see, and some of it you can. So I'm going to type in, let's just do San Antonio for fun, where I'm at. If we click San Antonio, you see our project. And this is actually a pretty cool little tip for those of you who have used this, and I don't think this is documented anywhere. The 59 series weather stations are the National Weather Service weather stations, and these are going to be the same ones that like Train Trace use, and they're almost always at an airport. So you can zoom in and see, sure enough, that's an airport. Interestingly enough, there's a bunch of airports in San Antonio because of all the Air Force bases. I guess anybody who joins the Air Force always comes to San Antonio. It's literally the first place they have to go to Lackland. So there's multiple weather stations, although I only see 159 here. So even though it might be a little further from my project, if you were trying to compare or be more in line with what the mechanical engineer is doing, you could pick this. It's not that critical. There are some reasons to not pick the closest one if there's a big elevation difference or you're next to a large body of water. So weather station is selected. I hit OK.
Location and weather station, right?
What's that?
Location and weather station. That's what that you just selected.
Yeah, right. Location and weather station. So now I have to delete the energy model. Now we're just seeing the mass and recreate it. And you can't, like I said, there's some things you can't see. So you can't actually see where the location is. But interestingly enough, you see some other details. Remind me to show you this later, where some really granular details are that just based on the building type, the building use type, though, there's a whole bunch of things that are picked for us as architects, not having to worry about air changes per hour. And you can if you want, but you don't have to.
Awesome.
So now that we've visually validated this thing, just to make sure there's no big mistakes, that's one of the big points of having seeing the energy model in Revit.
Definitely.
And we can push it out. So we can click generate, and it's always prompting you just in case you haven't looked at the model and you've made some changes to it. If you haven't looked at the energy model and you've made some changes to it, you can have it update before doing it, before pushing it out to the cloud. But I always like to have just looked at it. If I saw this and realized I didn't look at it, I'd cancel and have a look at it before, rather than doing this, which could theoretically change something that I was just looking at, right? So the really interesting thing about this workflow is we have the geometry. There's a couple little settings in the energy settings, and we've specified the location on Earth. That's all you need to specify, even for a more detailed Revit model, to start getting accurate results. So the obvious question is, what things did I leave out that seem like they should be really important?
Sorry,
That's all right.
You can keep going. They can't see it right now, but it looks like my camera battery's about to die. So let's keep rolling through the process, and I'll try to make sure my camera doesn't die on me.
Okay. All right. So the question I asked and the answer, well, the question is, so geometry, some energy settings, and location are all you need. And the things that are missing, and in a lot of ways they don't matter until they matter, are things like the assembly, the wall assembly and the roof assembly construction, specifically what they are, the window to wall ratio, the orientation even. It actually doesn't matter yet. When it does matter, we can specify it in Revit. But in the meantime, we have this really interesting thing that happens where it actually calculates a range of values for each input. So from within Revit, we clicked generate on the Analyze tab to push it out to the cloud. And you have to be logged into Revit, and so you have to have a legit version of Revit and be logged in to actually push it out to the cloud. But then once you do that, you can click this optimize button, or just go to insight.autodesk.com, and you'll see all the projects that you've run in the past. all the new projects just get dumped into this all uncategorized section. And you never want to leave the project here, but you'll at least be able to see that the project is here and it's already done. So I'm going to back out one level by clicking Insights. I'm going to create a new insight. And I didn't give the project a name. I remember I opened a new project and it's called Project One up here in Revit. So unfortunately, that's what it's called here. And then it created this new untitled insight, which I can rename. And you can also upload an image. If I scroll down, you can see some images that I've replaced for some tiles. So I'm going to open up this project. And now we're basically stepping away from Revit. And let me maximize this. There's the very first thing you want to do is come over here to settings. For most people in the US anyways, you're going to want to switch from metric to imperial. And then Autodesk defaults to cost. And once you're in the run, you can toggle back and forth easy enough. But I always like to have it at EUI. This is the KBTU per square foot per year. KBTU per square foot because we picked imperial. We'll come back later and talk about sorting widgets by importance. But the last thing that's really cool is because you've specified the location and Insight exists in the cloud, it has the ability to tie into some national utility rates. So for San Antonio, it's listing the electricity rate and the gas rate. And if you remember that white paper that I said I worked on earlier, it's really interesting to look at how the same building performs in different climate zones. So where I used to live in Duluth, Minnesota was in climate zone 7. And depending on the utility rate, which can be, the reason for how much utilities costs can vary, but one of them is often, is it hydroelectric versus coal-fired electric? And so you can see a difference. The EUI isn't tied directly to the electricity rate or the utility rates, I should say. There's ability to override that if there's some special reason to. And then right before we open this, one other thing I like to do is switch this to this rows and columns view so that you can actually compare different runs. If you're going to do a 4-story building that was more spread out on the site versus this 8-story building, you can do that. But the columns can also be adjusted. Again, Autodesk is defaulting to cost for everything, but we can click on this and select. The ones I like to select are the EUI mean. This is essentially the average of that range of values that we haven't looked at closely enough yet, maybe for that to make sense to everyone. The building area, remember we talked about it being 30,000 square feet. The ASHRAE 90.1 baseline. And then actually, if you close this side panel, you can get a few more columns snuck in here. The architecture 2030. So this is coming out of the 0 tool. If we're going to meet the 2030 commitment, this building needs to be roughly 22.8 for an EUI. The ASHRAE 90.1 code-based actual run baseline here is 70.5. And I don't really have a good extra one for that.
So, no, that's awesome. So I think I have a couple questions for workflow, but I wanted to try and answer. There's a couple great questions here from the chat. And from Junior asked if you had to model in 3 phases, would you have to create 3 different energy models? I think that kind of ties into a question I'm going to ask. So let's wait for that. And then Scoured asked about dealing with curved versus straight surfaces. So I guess, if you had a mass that had curved surfaces, how does the energy model react to that? Is there some tips and tricks with that?
Yeah, just like you saw when I was kind of twisting and manipulating the 8-story mass, that would have worked. Those were some pretty complex curved exterior walls, right? Curving in multiple directions.
So the analytical surfaces will be non-coplanar surfaces. It won't straighten them out or anything, or segment it, right?
Oh, right.
Awesome.
Right. There are some jigs and jogs that show up that look a little funny because of the voxel algorithm.
Yeah.
But at the end of the day, again, the idea of it not being the best, but being the best.
Well, right. Exactly. And that's the point is and to your point, the whole baseline thing is really, to me, if you unless you're using this to identify that you're meeting standards, right? If you're just using it as a tool to understand the impact of your design decisions, that's where it's huge, right?
Yeah, and we're not doing anything that's meant for code compliance or anything that we're going to take to the bank, so to speak.
Right.
ASHRAE 90.1, if you go and read Appendix G, it's really great. It's all about doing preliminary early energy modeling. That's where it talks about requiring the thermal zoning. But right at the very beginning of that appendix, it says, this is not meant to predict final project results. You're like, wait, what? But it's not. That's not what we're doing. We're looking at reducing the loads through passive strategies and things that will make the requirements of the HVAC system further downstream, like by the mechanical engineers, need be smaller and need less
understanding the impact of decisions, right? I mean, that's what's huge there. So Yvonne and Junior had similar questions about materials, and so I think this may be it basically, when do materials get considered? And so I think go ahead, sorry.
Oh, they've already been considered, and that's where this mean is coming from.
Yeah.
Well, what do you mean they've been considered? We're gonna look at that next. But any other questions before we open it up?
I think there was one last one with Jesus asked, is there you said it was free, but he's asking if there is a credit per project. So I guess thinking of the cloud stuff, is there are you using cloud credits to run this basically? I think
no cloud credits at all. It's amazing. And like I said earlier, this is actually, even BIM 360 is all on Amazon servers, and so running these calculations require compute power, and I think it's pretty awesome. I hope it stays free. It's been free for a long time, not free to Autodesk, even though we're paying them plenty of money. I don't expect.
Right. I'm sure it's built in somewhere. Come on, Dan. Come on.
But at the same time, a lot of people are leaving this opportunity on the table, which is really unfortunate.
So I guess my question is, and maybe you're going to this next as far as the workflow, is if you wanted to now modify the settings is one thing to tweak this, but what about modifying the building? So let's say you wanted to rotate it a little bit. What does that process look like for rerunning this to see the impact in this same model, basically?
Well, to get a different volume building, not necessarily rotate it, because that's already included in what we're going to look at here.
Okay.
4-story building that has a bigger floor plate. That would be a different project name. Okay. You push it out to Insight, and it lands in this catch-all category. And then once it's done running, you're going to select Add Model, and then just go pick that new project. If you actually change project one, this design, of course, is going to continue to evolve. If you push the same project out, it'll automatically find its place out here in basically replacing this project.
Got it. But it'll be a new model, essentially, a new energy model, right?
Yeah. Inside here, there's a little bit of a remnant of what happened in the past. Sort of like over here is a comparative analysis of the different runs that are done, but different runs are generally meant to be different project designs, not a tweak.
And I think that goes back to Junior's question about phases. I think you would make an energy model per phase, basically. You would, and then they would be run as their own models in this,
well, phasing is a little bit different, and I have an example. How long are we planning on going?
We got another 5-10 minutes, I'd say.
Oh, so we're only got 5-10 minutes.
Yeah.
Okay. Yeah.
I mean, unless you want to be here all night, it's up to you.
But... No, I took more time than I thought I would. There's a lot more to show.
That's usually how it is, which is fine. There's nothing wrong with that.
But orientation and and window to wall ratio. Remember I said we set it to 30%? Well, the triangle is the BIM setting, and it's already calculated all the window to wall ratio options for the north side. So right now, because remember it's a mean, it's giving us this average value. So if we know it's going to be 30%, we would dial this in. But if the client said, well, I want it to be 80%, we could drag this over and see the immediate impact on the EY. It looked like a small adjustment, but that's per square foot per year. So that's this 30,000, 2 point something times 30,000. So this should make sense. You'll see the wall construction. So materials, this is calculating all these different wall types. And since we're so short on time, I do want to show a couple other things in another model real quick.
No problem. No, that's awesome. I haven't seen that area of insight where you have all the different little aspects of the model, and then you can tweak them and see the impact. That's great. So
here's this shows like a lot of the bells and whistles of a model, the conversion process. So here's a wall that goes down and has a basement, but maybe this is a tilt up precast wall that goes from top of footing up to a parapet that's a certain amount above the wall. Here's a mass element, and it has some actual windows and an actual Revit roof superimposed on the mass. And then this, generally speaking, if we're in the existing phase, let's say this is an existing building, this would all be calculated as an exterior wall, right?
Yep.
But when we create the energy model here, it's actually going to make this coplanar area an interior wall. It's going to create the, and I got to duplicate this, and I won't bother renaming it. So it turned that Revit roof into an actual roof. The roof that is the part of that same roof element that's an overhang became a shade surface. So it's not relevant in terms of an EUI or thermal transmission, but the rest of that roof is relevant for blocking solar heat gain, for example. And there's glass here that showed up, and if we pick this wall, see it's an interior wall, and then this exterior wall got broken up into underground wall. The parapet is a shade surface. The exterior wall has an R value. And one thing I wanted to really also quickly show, so this is showing sort of the range of things. There's a slab on grade, an interior floor, and then a below grade floor. But if you're plugging in something based on like ASHRAE 90.1 for climate zone 2, if you have a steel framed building, it requires R13 plus R3.8 of continuous insulation. And so I've mentioned previously that the inputs don't matter until they matter. But once you decide what the exterior wall construction is, there's still a way of setting this in a simple way instead of having to go in and edit the Revit materials. At first pass, everything is based on these settings.
Right.
And then if you go into this next dialog box and check exterior walls override, now you have a whole bunch of options here, including a straw bale wall type. Or remember that code requirement we were just looking at, R13. There is an R13 R13 3.8 metal frame wall. That's what we picked. So that would be R16.8, right? And I'm curious, should it be R16.8 when I create this? Does anybody know?
I don't know. No one else knows either.
So if I select it, it's R9. And that is actually absolutely right because of derating that needs to happen because of thermal bypass. So here's a blog post that shows this idea of the ASHRAE 90.1 value, picking that same thing in Insight. But if you calculate this, there's a document that Autodesk has on their website to calculate what all of these, it shows the details of what every one of these wall type options are. So this is the R13 plus 3.8 metal frame. If you do all the math on this, which includes the derating of the insulation because it's not continuous, right? Its studs are stopping and starting. And then the metal studs in particular, have poor thermal a lot of thermal bypass. So the actual R value is 9, not 16.8. And that's exactly then what gets pushed into the DOE 2.2 energy modeling engine, or the Energy Plus modeling engine.
So that was awesome. So now that you have Revit Elements, right? If you didn't check that override, it would use whatever properties were built into the Revit element, which is pretty cool. But you have the option to check that box and select from a pre-selected list of materials.
So yeah, there's actually a hierarchy here. So here's like super simple exterior wall options. Is it lightweight or high mass construction? This is that thermal resistance thing. And then for each of those two categories, what climate are you in? Just super simple. And then there's an override for each one of those categories. Like for glass, there's also quite a few options here to get more specific, but this is for all glass everywhere, right? And for the exterior wall, it's for all walls everywhere. So that there oftentimes becomes a point where this doesn't quite work, right?
Right.
At that point, you check this box. And when you do that, if you select this wall and go to edit type and edit structure, see how this wall has a R value and a thermal mass value. And I've written blog posts on how you can actually tweak the materials to account for the weighted approach of studs versus insulation, and do the derated method, right? But each one of these layers,
for that, you would have to derate them when you're setting up the materials, right?
Yep.
It won't derate the material during the energy model. We'd have to.
And this is a pretty cool workflow. So this insulation, its thermal properties times 3 inches is how it's working. If we go look at the thermal assets for this particular material, thermal conductivity, specific heat, and density are the 3 that are important to what we're talking about. And basically it's those times 3 inches, because obviously if we make this 6 inches, the R value should shoot up quite a bit, right? And then brick has a higher thermal mass than other materials. So that, retains and then it releases heat in a specific way, and that's accounted for here. And all of this stuff then is plugged into DOE 2.2 or Energy Plus, which are industry standard energy modeling engines. I'm actually writing a blog post right now for Lake Flato's blog, comparing a Revit plus Insight analysis that we did to Rhino and Climate Studio, just to show that, if you have the same inputs, you should expect to get the same results. And I mentioned earlier that if you pick like the building type as office, this is a little harder to find because most of this area that I just went to is for mechanical engineers. But when you pick office, all of this information is plugged in to calculate that ASHRAE 90.1 baseline, which includes things like the occupancy schedule. So down here, there's actually like residential home occupancy. So people are gone during the middle of the day, but home at night, right?
Mm-hmm.
Versus an office occupancy or schools. Interesting thing about schools is buried in this is actually that the U.S. national holidays, which isn't good for people outside of the U.S., but that's a handful of days in addition to what you see here. So there's a lighting schedule, a power schedule, the heating and cooling set points. You can adjust all of this, and this will be what is actually entered into the energy model.
Awesome. Actually, someone did have a question about can it be tweaked to outside of U.S. standards?
So yeah, basically this at some point this is more about physics, right? Than the US versus other standards. And so to do the climate studio analysis, I had to go into project units and change everything to metric so that I could so I didn't have to do the math.
Right.
Then I could, once I changed all that, all the stuff listed here was in, watts per hour or whatnot. So all of that ends up working out just fine. The weather stations are available all over the world. If you go in here, and we're working on a project right now in Argentina. So here's several weather stations.
Oh yeah, look at that. Awesome.
So I could keep going on and on, but I better stop.
No, this is awesome. This is perfect. I think the workflow and sort of recapping, the having a massing floors, creating the energy model, making sure the settings look right, and then uploading it to Insight, checking the stuff out in Insight. That workflow alone is simple enough, but then also developing the building and doing it again, right? So and then being able to compare. Not to mention the stuff on Insight that you showed, just being able to go in and tweak those settings and understanding that these are averages across the board and you could refine more. I mean, that alone to me is awesome. Super, super valuable stuff. And I hope people find the same value I did. So I appreciate it, man.
Yeah, we do this on all our projects, from single family residential projects all the way up to really big projects. So
yep.
It really comes down to just making the time to do it. And I'd even recommend you do it on your own time, because it's going to, be professional development opportunity for you.
Yeah.
The company you're working for isn't doing it.
Right.
Maybe the company's going to appreciate the fact that you spent a bunch of time figuring it out on your own.
Yeah. Like, are you sure? Or maybe you're an intern and you want to, or a junior architect and you want to be able to critique one of your boss's designs.
Yeah.
So
yeah.
Look at this terrible design. No, I'm kidding. Awesome.
It does require models to be created generally accurately. You can't use floors for countertops and do those. Yes. Some of those things you can select and make non-room bounding, and then Insight will ignore them. But generally, though, you can run into problems more so than you asked about massing problems. Yeah. There's more often problems
with building
with
elements.
Models.
Yeah, I'm sure. But I'm sure over time you see that. I mean, honestly, from what you've showed me, it already seems like it's doing a better job creating the analytical surfaces than back when I used it. So that's all good. Awesome, man. Well, thank you so much again for joining. This has been great. This has been really cool. Dan, I'll make sure to have as many links as I can. And if you want to shoot me a list of any ones that you want added, Dan, I'll make sure to add them to the blog post, as well as the YouTube description, as well as where folks can find you, whether it's on Twitter or at BIM Chapters blog. Any final words before we wrap this thing up?
No, thanks for having me on. Nice to get on and share some of this info, and good luck reaching 50,000. If you haven't,
I haven't checked. Maybe we did right now. No,
if you haven't subscribed to this, you're watching now or recording.
Thanks.
Subscribe.
and just for and I appreciate you continuing on. For anyone who didn't see what happened because you didn't see me, my camera battery. I actually use a camera that it's plugged into the wall, but for some reason something happened and the battery, something's going on there. But basically the camera went down, and while Dan was teaching, I was scrambling finding a charged battery to flop in this thing. So thanks for sticking with it, Dan, while I was like jumping around and screen behind you there.
Yeah, no problem.
Awesome, guys. Well, thank you guys for joining us tonight. I really do appreciate it. Thank you to Polycam for sponsoring this episode, as well as Enscape for sponsoring the tip of the week. Again, next week we're going to be live on Tuesday night at 9 p.m. talking about Polycam, so stick around or tune in for that. Definitely subscribe to the channel here. And with that, I want to wish you guys all a happy weekend, and thanks for tuning in, and we'll talk to you later.